everyone, welcome back to our channel. Today, we will learn something that is typically considered an intermediate concept. Sometimes it also appears as an advanced concept. But for your benefit, we are adding this topic in our beginners series. Learning this will consolidate your understanding better. Do not worry, we will explain this in a very simple way. So without further ado, let us unveil the concept slowly with a series of motivating examples. The concept is essentially learning data types for various collections of items. Remember, earlier we learned the data types of simple variables. Today, we will further dive deep about those variables which are some collection of items. And we will start with the data type called list. In many day-to-day affairs, we often use the term list. We say, I have a list of things to do, or I have a list of friends to invite, and so many things like this. But in computer programming, the usage of the term list is reserved for specific cases. Let's understand more about it through an exciting example. For example, suppose there is a temperature sensor placed on the ground by the scientists to monitor possible volcanic eruptions. This device emits temperatures every hour and a receiver collects them. Now, as computer programmers, suppose we have to store the temperatures for creating plots, analyzing the trends, and so on. The question is, should we store the temperature in the order they arrive, or can we store them in any order? In this case, since our purpose is to monitor a possible eruption, it is important to plot the trend in the temperature. Are they rising, or falling, or plateauing? So the order is an important aspect of storing the data. For all situations like this, where we need to maintain the order, we can use a list. A list keeps the items in the order they are added. Let's give you a contrasting example. In another case, suppose from these temperatures, all we need is to plot some histograms. Calculate mean and median. Since none of these require keeping the order of the temperatures, can we still store the temperatures in a list? The answer is yes, of course. But computer scientists have provided another data type which can be more efficient when the ordering is not required. This data type is called set. So without further delay, let's take an example, very simple one, to see these two concepts in action. See, val1 is a list, whereas val2 is a set. Here, val1 is a collection of items where we add temperature 12.34 first, then we add 55.12, and finally we add 25 twice. Once added, the collection remembers the order they are added. When we design a collection that remembers the order of addition, we call it a list. Similarly, for the collection of items val2, we add temperature 12.34 first, then 55.12, and finally we add 25. But unlike val1, in this case, val2 does not remember the order in which the temperatures were added to it. It just knows all the temperatures it contains. For situations like this, we design collections that do not remember the order of addition, and we call such a collection a set. The behavior of the set data type is very close to the mathematical set. A mathematical set does not keep the items in order. So is the set in Python programming. Not just the order, just like a mathematical set does not allow duplicate elements, a Python set does not allow storing duplicate items as well. To understand the idea of duplicate items better, Suppose we don't care about remembering the order of insertion of items in val1 and we want to store all items of val1 in a set. Then we have to store 12.34 twice and 25 twice. But duplicate items are prohibited in a set. So we still cannot use a set to store the items of val1. Remember that not just the order but also the presence of duplicate items are the key considerations when a programmer chooses between a list and a set. You might wonder then when should we use a set? Remember, when we don't need to maintain any form of order among the items and when items cannot be duplicated, we should favor using a set over a list. Now that we understand when to use a set and when to use a list, let's see how any stored item can be accessed. Suppose we want to access the second item of the list and print it. We can use the same index-based syntax that we have used for accessing the second character in a string. Let's see this in Colab. See, it prints the second item, 55.12. Now can you tell me how do we print the second element of the set? Should we use the same syntax used for a list? Any thoughts? Well, the answer is no. Remember, we said a set should be used when there is no need for order among the items. So if there is no order, there is no sense in identifying first element, second element and so on, right? This is why a set does not allow such an access by index operation. If you are curious what kind of operations does a set support for accessing its items, it indeed supports accessing all items one by one, just not in any particular order. And you might be surprised you don't need anything fancy for that. Just a for and loop command would do. Well, let's see this in Colab. See, it prints all the items. Along with accessing all items by loop command, a set also supports another operation to check if an item is in the set. For that, there is no need to use anything new. We can reuse in command we have learned in for and loop. Let's see this in Colab. We write print 12.34 in val2. See, it prints true because 12.34 is indeed present in the set val2. Next we write print 12.35 in val2. See, prints false because 12.35 is absent in the set val2. Now let's understand a bit about inserting items in lists and sets. Both the data types also allow inserting new items. For list data type, the operation is called append to emphasize the fact that this operation internally inserts at the end of the list. Whereas for set data type, there is no order, and that's why there is no head or tail in a set. So the term append is meaningless for sets and never used. Instead, we use the term add for inserting elements in a set. Let's see this in Colab. Let's see the insertion commands for both list and set types in Colab. This example also shows another interesting property of lists and sets in Python. Did you notice that we are now storing strings along with the already stored numbers? This kind of mixing of different types, strings, numbers, etc. in a single collection are not allowed in Java, but Python allows it. In fact, there are many such differences between any two languages. It's because each language has some target objectives and the design decisions are also focused on those objectives. That's all for today, but we continue our discussion on the collection types. Next time we see another group of motivating examples using the same temperature sensors and receivers. See you soon. Ciao.